turn to your next blank page in your journal, put today's date at the top, and the title of today's lesson is Lesson 6-4, Quadrilaterals. We're starting out with 4 vocabulary words today. Please make sure you write them as in double column note form. So here are 4 vocabulary words. Our first vocabulary word today is polygon. You need to know that there are 2 criteria that make a shape a polygon. A polygon has to be closed and it has to be made up of straight lines. The next vocabulary word is regular polygon. A regular polygon is a special kind of polygon that has all sides that are the same length and all the angles have the same measurement. An example of a regular polygon would be a square because all of the sides are the same length and all of the angles are the same measurement. They are all 90 degrees. Third, we have parallel. You need to know that parallel lines are lines that are the same distance apart and will never cross. So think of railroad tracks. Railroad tracks are always the same distance apart and they will never cross. So those are perfect examples of parallel lines. Next, we have perpendicular lines. Perpendicular lines are lines that intersect to form a right or 90-degree angle. Here's an example of perpendicular lines. Because notice when my lines cross or intersect, they form a right angle. Here is another example of perpendicular lines because I still have 90-degree angles formed. Please hit pause and copy your vocabulary into your journal. In your journal, I would like for you to write, what does the word quadrilateral mean? And then let's talk about what the word quadrilateral really means. Most of you know that the prefix quad means 4. Lateral means sides, so quadrilateral means it has 4 sides. So answer in a complete sentence, please. Quadrilateral means 4 sides, and there's more to that definition for 6th graders. It also means that if it has 4 sides, it must also have 4 angles. So you need to know that all quadrilaterals have 4 sides and 4 angles. Next, we're going to look at some different kinds of quadrilaterals. I want you to name the shape, draw the shape, and list all of the information about each of the shapes on the following slides. So the first shape you have to know, of course, is a rectangle. And here are the important attributes of a rectangle that you need to know. You need to know that opposite sides are congruent or equal. Now, here's how I showed that they are equal. I know that the left side is exactly the same length as the right side. The opposite sides are congruent. I'm going to show that by putting 1 hash mark on either side. This tells me the sign with 1 hash mark is equal to the other side with 1 hash mark. I know that the top and the bottom are also equal. Now, if I just put 1 hash mark, that tells me 1 hash mark is equal to the other sides with 1 hash mark, and that is not true. So I'm going to put 2 hash marks on the top and 2 hash marks on the bottom. That tells me the top and the bottom, since they each have 2 hash marks, they are the same length. The next fact that you need to know about a rectangle is that those opposite sides are equal, but you also need to know that they are parallel. So the top line and the bottom line are parallel, and then the left side and the right side are also parallel. The last fact you need to know about a rectangle is a rectangle must have 4 right or 4 90-degree angles, as you can see with the boxes that are drawn in. So if you can answer yes to all 3 of these questions, that will help you determine whether a given polygon is a rectangle. Now let's move on to a square. Here are the facts that you need to know about a square. You need to know that all sides are congruent or equal. Since all sides are the same, I'm just going to put 1 hash mark on each side, showing that all 4 sides are equal. You also need to know that opposite sides are parallel. So the left and right sides are parallel, top and bottom are parallel. Also, similar to a rectangle, a square also has 4 right or 4 90-degree angles. Here's something else I want you to notice about a square. Since a square has all equal sides and all equal angles, we can also say that a square is a kind of a regular polygon. Remember, a regular polygon has all sides that are equal and all angles that are equal. Next, we have a parallelogram. Here's what you need to know about a parallelogram. A parallelogram is similar to a square and a rectangle in the fact that opposite sides are congruent and opposite sides are parallel. So that means the left side and the right side are both parallel and equal. Then the top and the bottom are also parallel and equal. You also need to know for a parallelogram that opposite angles are also congruent. For example, if I take the top left angle, that's an obtuse angle, so my other opposite angle from there, my other obtuse angle, is also equal to this measurement. So this angle and this angle, opposite angles, are congruent, meaning they have the same measurement. Notice I put 1 little mark in that angle and 1 in this one. Also, this acute angle and this acute angle are also congruent because they are opposite from each other. Next, we have a rhombus. For a rhombus, just like all of the other quadrilaterals we've talked about so far, has opposite sides that are parallel, and a rhombus also has opposite sides that are equivalent, but it just so happens in a rhombus, like a square, all sides are congruent. Just like all of our other shapes also that we've talked about so far, it has opposite angles that are congruent. So, this acute angle is the same degree as this acute angle, and this obtuse angle has the same measurement as this obtuse angle. Now, some people want to call this a regular polygon like the square, but it is not a regular polygon because all of the angles are not equal. All of the sides are equal, but all of the angles are not. Therefore, it is not a regular polygon. And the last quadrilateral we're going to talk about today is a trapezoid. The most important thing you need to know about a trapezoid is that a trapezoid has exactly 1 pair of parallel sides. So, in this example of a trapezoid, my 2 parallel lines happen to be the top and the bottom. I also want you to know that those two parallel lines have a special name. Those two sides are called the bases. The two parallel sides are called the bases. One of them is called base 1 and the other is called base 2. Now, it doesn't matter how my trapezoid is turned or rotated or looks, it will always have exactly one pair of parallel sides. Here's another example of a trapezoid that I would like for you to draw in your journal. And it is a trapezoid because I have exactly one pair of parallel sides. The top and the bottom are parallel. The left and right are not parallel. So it has exactly one pair of parallel sides. Please draw this example into your journal. And here is yet another example of a trapezoid. This is a trapezoid because this time the left and the right sides are parallel, but the top and bottom are not. So it has exactly one pair of parallel sides. Now, there's a special kind of trapezoid, and this is an example of one here. This is what I would call an isosceles trapezoid. Think back about an isosceles triangle. You know that an isosceles triangle has two equal sides. Therefore, an isosceles trapezoid is going to have two equal sides also. In this case, the left side and the right side are congruent. Here's something else special about an isosceles trapezoid. Just like in an isosceles triangle, there are equal angles. But in an isosceles trapezoid, the two acute angles are equal. So in this example, the two bottom angles are equal. Then the two obtuse angles are also equal. Okay, now let's practice classifying some different quadrilaterals. I would like for you to draw the quadrilaterals in your journal, and underneath each one, let's give each quadrilateral as many different names that fit as possible. And we're going to start with the more broader general name, working our way down to the most specific. So let's look at the first rug on number 1. I know that it is a polygon because all sides are straight and it's a closed figure. Since it's a polygon that has 4 sides, I can also call it a quadrilateral. Then it has a more specific name than just quadrilateral, and the most specific name I can give it is a parallelogram. Most of the time when I ask you to name the polygon, I want the most specific name possible. But you also need to know that I can also call this figure a polygon, and I can also call it a quadrilateral. Now if you would draw the second rug, and notice on the second rug, each side has one mark. So I know that all 4 sides are the same. So I can start out in general and say that this figure is a polygon. Since it has 4 sides and 4 angles, I can call it a quadrilateral. Since opposite sides are parallel, top and bottom parallel, left and right parallel. Since opposite sides are equal, top and bottom are equal, left and right are equal. And since all 4 angles, or excuse me, opposite angles are equal, I can also say that it is a parallelogram. Since it has 4 right angles and opposite sides are parallel and equal, I can also call it a rectangle. But then most specifically, since all four sides are the same length and all four angles are 90 degrees, the most specific name I can give this is a square. So notice this figure has lots of different names, with the most specific name being a square. I could even, instead of calling this a polygon, I could be more specific and call it a regular polygon, since all the sides are equal and all of the angles are equal. So I'd like for you to sketch number 2. And on number 2, notice that the left and right sides are parallel and equal. The top and the bottom are parallel and equal. And I have 4 right angles. So let's start by naming it. I can call this figure a polygon. Since it has 4 sides and 4 angles, I can call it a quadrilateral. Since opposite sides are parallel and opposite sides are equal, and since opposite angles are also equal, I can call it a parallelogram. But even more specifically, since it has the 4 right angles, I can also call it a rectangle. I would like for you to sketch number 3 in your journal. Hit pause and give this quadrilateral every kind of name you can come up with. When you're ready to check, hit play. Okay, let's check your work. Since it is a closed figure made of straight lines, I can call it a polygon. Since it does have 4 sides and 4 angles, I can call it a quadrilateral. And I notice that it only has 1 pair of parallel sides. Top and bottom are parallel, but left and right are not. Since it only has 1 pair of parallel sides, I can also call it a trapezoid. Okay, let's look at this road sign on question number 4. Here's what I notice. I notice that all sides are the same length. I notice that all 4 angles are right angles. So let's give this figure as many names as we can. It is a polygon, and it is a polygon because it's made of straight lines that are closed. It's also a regular polygon because all sides are equal and all angles are equal. It has 4 sides and 4 angles, so it is a quadrilateral. It is a parallelogram because opposite sides are parallel and opposite sides are equal and opposite angles are also equal. I can call it a rectangle because opposite sides are parallel and equal, and it has 4 right angles. I can also call it a rhombus because it has 4 equal sides. Those opposite sides are parallel, and opposite angles are also equal, so I can call it a rhombus. But the most specific name I can give it is a square. Number 5, I would like for you to hit pause and list all of the names for figure number 5. Okay, let's check your work. You should have named this figure a polygon, a quadrilateral, a parallelogram, and a rectangle, with a rectangle being the most specific name you can give it. Now let's talk about more specifically about the angles in a quadrilateral. we've learned that all of the angles in a triangle have to add up to 180 degrees. But let's talk about the angles in a quadrilateral. I'm going to start by drawing a rectangle, and I know that all of the angles in a rectangle are right angles. So if I want to find how many total degrees are in all the angles of a rectangle, I could add 90 plus 90 plus 90 plus 90, or 90 times 4, which is 360 degrees. Let's look at a square. I know that a square also has 4 right angles, and it is also a quadrilateral. So I can again multiply 90 degrees times 4 angles to also get 360 degrees. So every quadrilateral will have a total angle measurement of 360 degrees. Here's another way that might help you. I'm going to draw a trapezoid, and I'm going to divide that trapezoid in half to form 2 triangles. I know that in this triangle here, that's a total of 180 degrees. I know that the top triangle here has a total of 180 degrees. So if I want to know how many degrees are in the whole trapezoid, I could also add 180 plus 180, which would also give me 360 degrees. So in your journal, I would like for you to put a big star and write all angles in a quadrilateral add up to 360 degrees. Now let's look at your worksheet that says measuring angle measures in quadrilaterals. First, let's start by naming our quadrilateral. I know that it has 2 sides that are parallel. So my top and bottom are parallel, but the left and right are not. So since it has exactly 1 pair of parallel sides, it is a trapezoid. And here's what I also notice. Notice I have 1 mark here and 1 mark here, meaning those 2 sides are equal. Since it has 2 equal sides, it is an isosceles trapezoid. And remember, in an isosceles triangle, it also has 2 pairs of equal angles. So if this obtuse angle is 105, what does this obtuse angle have to be? You're right, it also has to be 105 degrees. So if angle D, this acute angle, is 75 degrees, then angle E, which is also an acute angle, also has to be equal to 75 degrees. So the measurement of angle E is 75 degrees. The measure of angle F is 105 degrees. Let's look at question number 2. First, let's talk about what shape it is, what figure it is. I know it's not a square or a rectangle or a rhombus, so let's see if it's a let's see if it's a trapezoid. Notice the bottom and top are not parallel. Left and right are not parallel, so it is not a trapezoid. It's simply a 4-sided polygon, so it is a quadrilateral. Now, notice they want me to find the measure of angle M. So I know that if I add all 4 angle measurements together, I should get 360 degrees. So just like in finding the missing angle in a triangle, I'm going to add up the angles I know, and then I'm going to subtract that sum from 360 degrees. So let's add. We have 105, 140, and 55. 5 and 5 is 10, carry the 1. 1 and 4 is 5. 5 and 5 is 10, carry the 1. 1 plus 1 plus 1 is 3. Now, these three angles together equal 300 degrees. So to find angle M, I have to subtract that from 360. There are 360 degrees in every quadrilateral. So 360 minus 300 is equal to 60 degrees. So the measure of angle M is 60 degrees. I would like for you to hit pause, try number 3 on your own. When you're ready, you may hit play to check your work. Okay, let's check number 3. You should have classified number 3 as a trapezoid. It is a trapezoid because it has exactly one pair of parallel sides. The left side and the right side are parallel. Top and bottom are not. You also needed to know that those little squares meant those two angles were equal to 90 degrees. So let's add the three angles that we know. 30 plus 90 plus 90, that's 0. 9 and 9 is 18. 18 plus 3 is 21. So that's 210 degrees. But to find angle R, I have to subtract from 360. So 360 minus 210, that's 0, 5, and 1. So angle R is 150 degrees. Now I'm going to check that for reasonableness. I notice that angle R is obtuse, and I did get an obtuse measurement, so my answer is reasonable. So I know that the measure of angle R is 150 degrees. The measure of angle S is 90 degrees. And the measure of angle T is also 90 degrees. Let's look at question number 4. Let's start by classifying it. I recognize this shape as being a parallelogram. Let's think about what we know about a parallelogram. We know that opposite sides are parallel and equal, and we also know that opposite angles are also equal. So if angle C is equal to angle B, since it's a parallelogram, that means angle A is equal to angle D. So in order to find what A and D equal together, I'm going to add B and C together. So 130 plus 130, which gives me 260. I'm still going to have to subtract that from 360. So 360 minus 260 is 100. Now, I know that's not reasonable because angle A and angle D are both acute angles, and 100 degrees is an obtuse measurement. But notice, it's angle A and angle D are 100 degrees together. And since they are both equal to each other, I can do 100 divided by 2. So that means each angle, A and D, is equal to 50 degrees. So the measure of angle A is 50 degrees. The measure of angle D is 50 degrees. Your independent practice for today is to finish questions 4 through 8 on the back of the worksheet.